Hello.
Hello.
Good morning.
Hi, how are you?
Yeah, I'm good.
Good. So welcome. So yeah, I don't know. People wanted to give updates now, and we didn't have a meeting yesterday. We'll get to that in a little bit, but looks like Barshan and Ashu are here. And would you like to give an update?
Yeah, sure. So I submitted my work in a form of a gist. I can share that over in the group as well. It contains like an overview of my project and all the required links, like the Hugging Face link, the live demo, and everything that's required, and also to the GitHub. Other than that, yesterday actually, I got a call from. One second, I forgot his name. Just give me a minute. Let me just check. Okay, Shushmant, who was a past contributor of GSOC, I think 2023. So he called me yesterday. He said that he saw my GSOC work, and he mentioned that I should ask you if there are any he asked me to preprint this and publish this work in any of the conferences or any thing that is available. So he asked me to ask you about that. I was actually in the middle of a bit of work while he called, so I didn't pay a lot of attention. I told him to call me back as soon as possible if he's free. So we'll have a talk about that again. And other than that, I think, yeah, that's all. I think. And I'm looking forward to getting a preprint of my work and publishing it or whatever.
Yeah. Yeah, so that would be, of course, the next step is to get something in the form of a preprint. I have to talk about what that looks like. But yeah, definitely the next step. And also, I saw that your work was on Hugging Face. And I had mentioned that I was going to pull up our Hugging Face site. I'll do this Monday in DevoWorm if you have time.
All right.
Yeah.
Yeah, sure.
I thank you, Barshan. Ashu, are you there?
Yes, am I audible?
Yes.
So I have uploaded all the files to our GitHub, and I have created one more pull request, I think 2 or 3 hours back, and I have updated the README as well. Like,
Yeah. Yeah, so I got your pull request from the other day, but I didn't get the one this morning. I guess it would be this morning. So I'll check and accept that pull request. Yeah. So this is our pull request list here. So this is Ashu's new pull request. Enhance README with project structure and instructions. So I'll accept that. Actually, I guess I can accept it now. We'll just do that. Okay, there you go. Thank you for contributing. So this is add a detail repository structure, installation steps, key design decisions, incidents matrix explanations, and metrics for the dynamic HGNN project. Okay, and then that's this last pull request. And then we had a couple other ones. So this is another one from Ashu, number 72. This is some updates to files. And then we have this one here from Barshan. This is kind of like the last one that kind of closes out the submission to Google. This is number 71, and it just kind of goes through some of the data set things, the fate labels, node classifiers, etc. Thank you for your contribution there. Another one by Ashu, added the notebook for training loop, implement incidence matrix generation workflow. And there's some more back here. Barshan, cell-fate S-gel, a couple of them. That was a couple weeks ago. I think we've talked about those. So a lot of good activity in the DevoWorm organization. So yeah, Jesse is here as well as Morgan. So Jesse has a couple things in the chat. The first one is there a write-up I can mention for Ashu? I will make a compilation post eventually, organizationally, and can link both of their updates. Okay, yeah, I guess so. I'm not familiar with what this is about. Yeah, I would also encourage Ashu to do like a preprint of her work as well, because we'd like to have like different ways to communicate that work. So we have, of course, our pull requests and our meetings, but we also have these other artifacts that people can go to. So yeah, then we'll talk about that. And then I guess Sarrah's here, yes. And Jesse is, Sarrah messaged Jesse and myself, I think yesterday or the day before, about some things that she's working on for a paper. So I guess Jesse is going to respond in more detail. Sarrah is just, kind of working on that. Okay. So yeah, if you, and I know Sarrah wants to hit a target of a workshop for, I think, NeuroSim. So, if you don't make that, that's fine. You can continue to work on it and put it up as a preprint and just keep targeting different opportunities. It's usually, it's one of these things about like these engineering conferences where they want a full paper at the submission deadline. So you have to kind of produce a full paper. And if you don't hit that at the deadline, then you have to forego the opportunity. But there are always new ones coming up. So it's always a challenge. So yeah. So I don't know if Jess or Sarrah wanted to give an update.
Yeah, my major update to put on my administration hat. Basically, I don't know if you got my email or message, Bradley, but I'm putting together like an internal like memo, basically like a little alert for internal circulation only, whereas basically, um, ahead of making certain, I'm making a lot of like position or like internship posting or call for involvements, but I want to kind of I'm going around to all the different groups, and by like in JoPro and Orthogonal Lab and DevoWorm, whatever. But like, I want to say to people, like, if you want to develop a project, an existing project, or there's certain clusters that are forming around like assistive technology, some of the multi-agent stuff, even some of the teaching and learning, or teaching in like developmental course curriculum, or it was organization or research design. Like there's different clusters that are new, and there's a lot of existing projects, a lot of things from data and direction, that I don't know how much some people have been aware of, but there's this sort of opportunity for people that want to build something into the fall. And I wanted to internally just kind of say, like, hey, everybody, like, if there's a project that you want to work on, or it can be program development as well. And if you don't really know what the difference between there are, we can talk about them. But for those that want to build something out over the fall, this is sort of the week to let me know and let Bradley know, so we can otherwise, um, give you a discussion about it. And also, if it's something where you want to have, for example, um, if you would like to make a specific posting about your project where we advertise and say, hey, you know, for example, I'm going to use Morgan as an example. I don't think Morgan's doing this right now, but like Morgan wants to do, brain organoids project, and it's like, hey, through something specific through orthogonal lab, and it's like, hey, here's a project description, and we make a posting about it, and then someone was like, oh, it turns into a formal posting that we actually solicit or put on the website and advertise and get feedback, and then could have folks come in and do it. Um, but I'm mentioning this on purpose because one of the things I'm doing on the JoPro side of things is there's been a lot of really good. It's kind of like harvest, planting seasonal vibes. A lot of things grew to very good fruition um, over the summer, and obviously we're finishing up Google Summer of Code, and Ashu and Barshan have done all this great stuff, and Sarrah has these projects and that she's working on. So it's kind of like for those that want to, you know, you don't if you just want to work on what you're doing and you don't want to increase the level of involvement or have other people work on it with you, you don't need to do what I'm saying. But if anyone's at all interested in uh, expanding the project or expanding the role or specifically trying to ask, you can always ask your friends or whatever, but if you want us to build a something a bit more coherent or public facing and say, hey, if people want to work on this with us, um, we can do that. I'm in the process of doing that and sort of translating some of the summer projects and JoPro side of things and even something like Cognition Futures or the Diginest stuff and saying, okay, it's now time to make this portable and something that next iterations across terms and semesters and seasons, if you will, um, can be can be kind of built upon. So I'm just I'm particularly in that state right now. So I'm just I'll send out a memo about this or like some kind of like a small PDF explaining this a bit more with a little bit more background in the next few days. But that's my main update is just like, hey, now's the time if you're thinking about that to kind of indicate to me or Bradley that you want to do that. That's my There's a lot of other smaller updates I can say about individual programs and cool things about data and direction and um, some organizational things, but I'll come back to that later and see if anybody else wants to um, give comments or updates.
Okay. Yeah, that's great. Yeah, I've been kind of following what's been going on in JoPro, but of course you have a better handle on that. So I assume you've kind of tested some things out there, and now you're kind of bringing them to something that can be done more sort of, what the parameters of it are. So like data and direction, you've run that a couple of times. You kind of know what to expect there, how people make progress, all of that. So that's what you're kind of aiming for in terms of like, uh, I'm not really clear on the what like you're soliciting these descriptions for projects and things like that. So what are the lessons from what you've done in JoPro over the summer?
Well, I mean, in the data and direction sense, it's just that's intentionally a summer program, and there's certain people that are definitely continuing on with their program and or continuing on with their project, and so uh, like I'll make and one example is uh, like Violet is doing something on moral AI, and it's a very cognitive science and mechanistic approach and looking at very specific things. It happens to be LM focused, which I'm I'm appreciative of, but also I appreciate that her angle is less. Uh, she's aware of sort of I don't know. I'm kind of like LMs are great, but they're not everything. But how do we use that technology to look at these sort of broader principles as well? Which I appreciate her approach to about that. And so it's you know that's one person's project that could grow into a much broader um, effort. Like if people clustered around that, there could be a lot more work on that particular space. but that requires a certain structure being built to do so. And one of the things that I'm mentioning in terms of there's a few new groups of things that could take off into these sort of broader, like there's a lot happening right now in the space of essentially like assistive technology or disability related technology and accessibility. Like Jen is doing she's the clinical social work graduate student, and she happens to be working with a center that's dealing with people of different abilities in terms of uh, you know, like vision and certain things. And someone that I met at NICWIC, the conference like help co-chair ACM's NICWIC at a local New York um, computing conference, but someone there is a student who was making their own sort of apps that would help people who are blind or impaired vision, making apps specifically to help with that, given both modern technology and their experience as someone who was losing their sight. So we have Jen, we have this person's name's Tony, we have Avery, who has been um, modifying certain things in uh, like existing virtual reality things to make it better for people with certain conditions. Um, and then there's Flamello, who is one of the original data and direction folks who came back around, and she's doing her PhD in accessibility. So this is an emerging cluster of accessibility, assistive technology related people that are in the space, and I'm kind of like, okay, like, is there something to make here as a sort of a group project around that? So I'm kind of soliciting that as a formation into an actual, it could be interest group or people working on a project, or I'm speaking like I have an email to reply to Tony about like, hey, like, because Tony wants to further his ideas and do something in that space. So that's like one of the emerging clusters that could turn into kind of something in the fall. We talked about the multi-agent stuff before. We talked about, one of our people from data directs doing multi-agent stuff. We have people here doing multi-agent things. We have the history of stuff in orthogonal lab. It's sort of like it's kind of it's it's sort of a I know Bradley asked about lessons, but what I'm getting at is like the the macro lesson is like, hey, the fall semester's about to be here. So if we plan for something and have some intentional structure to what we want to do, and there's people internally who want to do it, okay, let's center and prioritize that and build around it. And then we can make some other like add calls for, we could offer internships or offer other things, provided people want to do that. So that's sort of the administrative lesson, is that now is time to do that. And I'm kind of doing. It's like I feel like I'm in the farmer sense, like, okay, I've got to get all of this fruit off the vine, and I need to take care of it, so that way, if we want to, you know, pickle things or preserve them, for later, we could do that, and then get ready for the next season, and then that's the next batch of things coming through. Um, so yeah, that's where I am, and the thing that I'll put out soon is like a bit of descriptions about some specific trends that happened over the summer. And that's why I asked like Ashu, or Barshan. I know Barshan has some write up in the blog, but like whatever your project is, if you have like your final write ups about it or made a presentation. I know I wasn't here the last week or so, and I can't. I think there wasn't a Friday meeting this way. But if you made a presentation about your work, and want it to be something that I'm kind of including as like, hey, recent events, recent strands, or recent projects that people can work on, or even if they're just interested in it, kind of bring it all together so that the existing community kind of knows, okay, here's what has been going on, and like here's what Ashu's been working on, and maybe Ashu continues that in the fall. Like if it's something that you do want to continue into the fall or winter or whatever, kind of just flag that. So people ask me all the time, oh, what's going on in orthogonal lab? Like, what's DevoWorm doing? And so just so I have like the latest thing to tell them, at the very least, let me know that or let us know that. And then when we're doing sort of more, as I'm writing all these bigger updates for, okay, here's a new full opportunity internship with a data and direction related project or something out of DigiNest or whatever, like I will be making all those updates and those like specific job or posting pages soon. So that's a bit what I'm getting at. I think there might have been other questions, and I can say more.
Well, thank you, Jesse. That was a good overview of kind of where you're going right now, and I'm glad to see that a lot of good things have been happening this summer with JoPro and some of the projects there. Yeah, we'll have to kind of follow up on that call. Looks like Sarrah's ready.
Yeah.
Hi, Sarrah.
Yeah, hi. I think I will go after Ashu for my main updates. But I just wanted to follow up on something Jesse said, right? So when we're looking at all the things you can do in the fall, one thing that has come up time and again in recent years, and that I think we need to look at as soon as possible, is adding guardrails to our GitHub in every format. So having whether it's like the actual settings that we protect, which branches we protect, how we keep a backup, but also apart from that, like having these kind of guardrails on PRs and issues, having making like some good tags on which issues are actually beginner friendly versus which are something that we wish to take up in the long run. There are also, so I attended this so the GSOC team did an alumni camp in Delhi, in two cities in India the last month in July. So it was Bangalore and Delhi in India. So it's like how they had the meetup. So they kind of upgraded from the meet. It was like a more than a meetup, less than a mentor summit. So it included both contributors and mentors throughout the years. And they just, so over there, I mean, I had discussions with a lot of people, and it was that same like unconfidence Google format. Right? So I held this one session myself, which was to address what we kind of faced last pre-GSOC season. Which I feel is like a lot of AI slop being put into pull requests in general. And I know a lot of other mentors faced it as well, because there was a lot of discussion on this on the Google mentors thread. So, so I kind of had a session on this because there were both contributors and mentors there, and I kind of wanted their perspective on it. So of course the contributors' perspective was because everyone is doing it, we feel like we need to do it otherwise we'll be left behind in the GSOC competitor zone. But I talked to mentors a lot, and one was like being able to spot if someone is genuinely working versus just like copy pasting everything into AI and creating a basic proposal. And that I think we have it sorted because we have these meets and we have people come in and kind of get to understand their dedication and what they're actually working on through these. So that region I think we don't have a problem on. But the pull request part, so a lot of these people said that they had bots. So they had kind of made their own Copilot bot or something. And one of them also shared a repository. I'll have to find it. I'll do it within the next week. In which he had made all of these like kind of agents.md files that would help prevent this. So they had everyone had different type of guardrails depending on like what they felt they needed. Like someone said that if you just created a GitHub account, which was less than a month old, then we would not allow you to contribute. Some had specific guardrails set up on their GitHub system where they said that unless this issue is assigned to you, you cannot link a PR to this issue. So basically, you cannot work on this issue. Some other people had an auto review bot, which kind of reviewed the PR, spit out suggestions, and only when the auto review passed would the actual mentor or maintainer take a look at the PR. So I think, I mean, if we are looking for something that we can do in fall, if we have group of people who can kind of just sit and add this, or maybe just make these bots, or at least we decide what we want to do. I think that'll be a good thing to take up, especially if we like, this will be ready for when we come into next year's PG season, right? So that's just something I wanted to say that we can.
Okay. Well, that's good to see that you've kind of pushed that conversation forward. So, do you have anything that you've written up on it, like a summary?
Yeah, I've not written up anything. It's all just floating around in my head. I do have some, so I'll just try to see if I can quickly find the repository that someone had shared. And I do have the notes from that written down, but it is in paper, so I'll need to find the notepad from that day. But
All right. Well, that sounds good. Thank you.
yeah, I mean, yeah, I guess if I find that, I'll send it here.
Okay.
Oh, but yeah. Yeah. Apart from that, I'll continue the rest of my updates. I think after Ashu, this is just something I wanted to, kind of pull Jesse's attention towards.
Okay.
Yeah.
Yeah.
Thanks.
Thank you. Ashu, I don't know if you had any additional updates or.
Yeah, so like I have completed the project and I will be preparing a project report for the work that I have done in this summer cohort. And for the write-up, I will be needing your suggestion. And so
Yeah. Well, that sounds good.
I
look
will.
forward to seeing it.
I think I will share the report by next week.
Okay. Sounds good. Thank you. I don't know. Morgan was ready to present, or to give an update, or if you want to do that later.
Yeah, if you give me just a little bit more time, I'm actually driving.
Okay. Yeah. All right.
And yeah, I'll queue up some papers and some links that just like to bring up too. So
Okay.
I'll be there in like 15 minutes.
All right. Yeah. Thanks. So it's been a while since we've done kind of going over the different weekly meetings. So the first thing is that I have a couple of weekly meetings to talk about, and then some content on the YouTube channel, which is related to a conference that I attended this week, and I'll go over that later on. But I wanted to talk about. I think it's the last time we met on Saturday. We had one DevoWorm meeting and one open source meeting. So I'll go over those. Now, our open source meetings, we're done with those for the year. So usually we run our open source meetings over the summer. And if, people are interested in talking about open source, we can continue to talk about open source in this meeting or in the DevoWorm meeting. But typically we just run our open source meetings through the summer. So this was kind of the end of our open source meeting schedule. And then in that time slot in the fall, we want to do some sort of new or different type of meeting. So that time slot will be open. And, we talked about things related to cognitive science, some things related to, maybe like large language models or things that connect the two fields. We have the cognition futures meetings, but those are a little bit different than what I'm thinking of for this new meeting series. So I don't know what that would look like necessarily, but we're thinking about doing this. So if people have ideas about what they want to cover or how they'd like to see that unfold, you know, you can you can solicit your opinions on
Yeah,
that.
and that's sort of like I'm drumming up all this stuff about like, hey, let's plan for the fall because I think the Friday time slot's going to be very interesting and it'll really to be what people want to do with it. I don't know. Have you? I think when you said I agree, and I don't know if you have any preliminary leanings. Obviously, it's for discussion, but like, did you have any preliminary leanings about like, oh, cognition, whatever related, but do you want something more like simulation based, or do you want something obviously maybe with more technical focus in terms of building or doing some of the stuff? But did you have any like anything that's kind of on your mind about that, Bradley?
Yeah, I guess that what you just described is kind of what I was thinking of. Like, so there's some sort of like focus on maybe simulations or on the technical aspects of cognitive science, different types of programming projects. Like I said, we could get back to the level of like working through a problem. Just that the just trying to build something from scratch or build something from parts. We used to do that a lot in the lab, but we don't do that much anymore. That'd be interesting from the standpoint that we don't get in cognition futures. Maybe also covering maybe some more technical topics that you don't get into in cognition futures, or for that matter, in a lot of the CogSci curriculum that exists. So
Yeah,
that's
I'm. Oh, go ahead. Sorry.
no, that's fine. Go ahead.
I think the most like if it was just today and we were deciding, okay, what is it going to be? I think basically what I'm seeing is because in I think this is in the like the draft that I'm sending around. I kept making things like saying things like, oh, multi-agent, whatever, blah blah blah. I think at its core, it's sort of what I would what I would be interested in doing is developing it's sort of an extension from the developmental brain break vehicle stuff, but just dealing with how do you like physically making well not physically, but creating the agents and creating the environments and then doing the testing in them. Like having that be like almost like maybe more of a studio or workshop focus. Like, hey, we're making stuff, but then oh, like the emphasis is a bit more on the foundation and that people want to like, oh, like, Barshan wants to do this or Jesse wants to do this or person C wants to look at this, that's fine. But there's sort of a core the core work of how do you set up the environment? How do you set up the agents? What are you testing? What do you need to do? What can you do? Like, what's the simplified version you can easily do on your own machine? You like that kind of stuff I think would be as a core I think that'd be a valuable thing that just isn't anywhere else in at the degree. I mean, it's in Google Summer Code type stuff, but having it be we're doing this with a sort of a cognitive agentic focus. Um, I think that because a lot of some of the like Alicia's program, or Alicia's project from Data and Direction was kind of hit a bottleneck of if she had more time to test that, that would be it. And also like this is completely overlap with Avery's agential work about like allostatic kind or some of the taxonomy work or like their agent personality things that's sort of Avery's jam. And there's been other interest in that in terms of you know some 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 of the excuse me some of the um like the moral AI thing that Violet mentioned is sort of in that space. So that's like three people plus people here that are already doing stuff in that space. So how do we make kind of a, if you will, a program? And by program I just mean like a meeting that has some structure in this case. Building around that seems like the most obvious thing to is put there. And we can talk more about that, but that's sort of I think that's my initial if unless we could find a better option than that, that seems to be what we would probably do Fridays, and I would certainly enjoy that, and I think that would be useful for the community and getting us into building and and making things that way. Excuse me.
Yeah, yeah, it would. So yeah, that's what we have kind of in the back of our minds for that Friday spot. So if you're interested, please let us know. We'll make an announcement on that soon. Ashu?
Hello.
Yeah.
Like me and one of my friends are working on quantum kernels and few short learning, in which we classify the things with very limited data. And in DevoWorm, the C. elegans data is also very limited. Like we have just planned the hypothesis that we are going to work on, and after experimentation, if the results are very good, then we can also use this for our DevoWorm and for predicting anything for C. elegans. Like the data set for C. elegans is very limited, and we can also use that work here.
Yeah, that would be good. Good to see. Let us know what you'd like to do. If you'd like some time to do that, we could make that happen. What is it, August 22nd today? So this was the DevoWorm meeting from August 10th. So this was, kind of one of the last DevoWorm meetings we've had. Morgan was here, Susan was here, myself, and Barshan was here. And we chatted about some things before his paper that I presented. So probably some things wrapping up GSOC, talking about different things. But then I presented on this paper on this topic of conformal invariance. So I mentioned that we've had this kind of interest in DevoWorm in creating mathematical structures around development and developmental biology. And one of those is this idea of a conformal map, which is where you take some data and you project it to a space. And you use that map to sort of describe that space in a different way. It's not really a latent space. It's more of a topological transformation. And the thing about these types of spaces or these types of maps is that it kind of pulls out sort of the regularized features of the data. So we've done this. We did this actually for Drosophila imaginal disk when we were doing that analysis. But this talks more about this idea of universal conformal invariance. And so this is where they look at some cell lines and they look at cell motility in those cell lines. So when cells are moving around, and they're able to characterize those different cell lines and find the commonalities between them. And one of the things you do when you're doing things like systems biology is you want to know about this universality between systems. So you might have a wide range of systems that you use as your input data. You might have, say, for example, C. elegans or Drosophila, or you might have some mammalian species. If you're dealing with cell populations, the cells are similar, but the behaviors might be quite different. But they also have some things in common. So what you want to do is find those commonalities. And so in this paper, they were looking at the emergent dynamics of collective cellular movements. They wanted to see how cells interacted with each other and how that drives their patterns of movement in development or motility in general. So how do they move together? How do they do things like migrate into, say, a wound to promote wound healing? Or how do cells move to effectuate changes in the embryo's anatomy? Things like that. So in this paper, they demonstrate that the flow is generated by collectively moving different types of cells. And in this case, they have a range of cells, including dog kidney cells, human breast cancer cells, and 2 different strains of pathogenic bacteria. So, we have bacterial cells, we have eukaryotic cells. we have different cell types that have different behaviors. And so this is all kind of, thinking about this idea of variation and how, even though we have a lot of variation and we're interested in variation, we want to find the things that they have in common. And so that's what they're doing in this paper. This is a formal mathematical framework. They show the precise form of invariance in all four systems as described by the Schramm-Lohner evolution, which is this family of planar curves, which you can define by a single parameter. And then they just basically point out that this universal conformal invariance reveals that the macroscopic features of living biological matter, which are these cells and the cell populations, exhibit universal translational, rotational, and scale symmetries that are independent of the properties of the cells themselves. So this is just kind of these sort of features, like I said, with the conformal map, where you have this transformation of the data such that you can identify these different things that different systems have in common. You can find the quote-unquote invariance. So this paper is quite interesting. I did a Copilot generated definition of the term conformal invariance and how this has been used. So this is typically an idea from physics and mathematics. So it's not something that a lot of people are familiar with outside of those areas. So I had to kind of teach myself about what this is. And basically it's this idea that if you transform data according to a conformal transformation, it's basically a mapping that locally stretches, rotates, or scales space. So it's a spatial aspect. It focuses on the spatial aspects of the data set. It stretches, rotates, and scales space while keeping the angles between intersecting curves unchanged. So you sort of protect a lot of the information, or you want to preserve the information of the structure of the thing, but you don't really care about everything. Everything in your data set should be, if there are these invariants, they should be scale invariant, they should be rotationally invariant, they should be sort of size invariant. So all these things can be found at different size scales, rotational scales, and other types of ways in which biological systems change. So and then this gives more of a mathematical treatment of it. So in physics, they use Maxwell's equation. They have these critical statistical systems. So if you're interested in things like criticality, that's something that is similar to this. So when you have a system that changes from one state to another very quickly, or it's poised to change state, those are things can be described with this sort of conformal invariance. And then Brownian motion, if it's in 2 dimensions, it's also conformally invariant. So it's just, there's a lot of sort of a physics language here that we need to kind of keep in mind when we talk about biological systems. Okay, then Hussain dropped by and he gave a little update on his work that he's been doing. And then Robin Gustafsson, who's been in the OpenWorm Slack, he also visited the meeting. He's going to present this next meeting on some of the work that he's been doing in Drosophila. So stay tuned for that. But Hussain came by and he talked about the work that he did with Richard Gordon, especially this stuff. So he gave this presentation on updates. He's done a lot of stuff in the last maybe 9 months. Let me see if I can get to this title page here. Kind of describes what he's doing. Yeah, so he's doing this stuff with what he calls RBYRCT, which is the sort of the derivative of the cancer physics work that Dick Gordon was championing. So this is RBYRCT is basically this imaging and analysis pipeline that he'll talk about in the meeting. He also has this theory, PCC EBID. This is a theory of complexity he's working on. This idea of ruleology, which is where you apply rules in a cellular automata, and you look at, this sort of invariance in biological systems. Membrane deflow, which is something that pertains to membrane modeling and some topics in early life. Spatial bubble farming, which is, so I don't think he talked about this in this update, and then spatial snowflakes. A lot of interesting stuff he's really been getting into lately. And so ray-by-ray computed tomography is this RBYRCT work where they have these X-ray imaging technologies that allow you to send rays through objects. And the idea is you have this volume of, in this case, tissue, and you want to detect a tumor. And so you send these different light rays through the medium or through the volume, and you send enough rays through there and you record the result of the ray on the other end of the ray where it's emitted from. And if you put enough of those rays together at different angles and orientations, you can get a solid picture of what's going on there. And the idea is you want to be able to integrate all of these images into a framework, filter out the noise, and find like something like a lesion or a tumor. So this is just kind of in the context of breast cancer screening. They're working on this Hussein's working on this technology with some collaborators, trying to get this off the ground as a startup and as something that's going to become like a series of papers. He went over that. He also went over this PCC EBID, which is the stability triad. This is this work he's been doing, this theoretical work called pressure, chaos, and control. And he presented on this in a previous DevoWorm meeting in the context of game theory and these non-transitive systems where you have a system where A is bigger than B, B is bigger than C, and A is also bigger than C. And so it's non-transitive from that point of view. And so, there are different ways you can model non-transitive systems. Most intuitively, the rock, paper, scissors game. But he's thinking about this in terms of a number of other topics in statistical physics and in complex systems. So he's working on this, and he wants to kind of advance this theory. And we talked about this. We were talking about this, especially with respect to the ever good regulator theorem. There's an opportunity coming up to do some work on work on some things related to cybernetics. So we'll talk about this in the near future in the Slack. But basically, I want to help him get this out and kind of work on this idea. Okay, so that we talked a good time with Hussain, and then this is the book Steerable Ray-by-Ray X-rated Computed Tomography. This is the book that's coming out that Richard Gordon and Hussain are publishing, and it has a number of really good chapters in it. It's not out yet, but it's coming out in November, I believe, November 30th. So that's, and then, we have a chapter in there. There are other really good chapters in there as well. All right, so this was, I can't remember what this was, but this was, I think, we had a paper that we did the previous, or actually, no. This is revisiting the same paper we were talking about, but I went, sometimes I'll go through like what the paper's about from the big picture, and then this is like the figures. So we went through figure by figure of that paper and like talked about what those figures meant. So that was the DevoWorm meeting. Now this is the open source meeting from I think the 14th. So this was where this is the last open source meeting we had. It looks like Morgan was at his parents' house, so it was a different setting for him. We had some discussion about some things going on in the San Francisco tech scene. And then Barshan gave a presentation on the interface that he had created for his SGEL framework. So this is the interface. This is available through the repository. There's a link to this in the repository where he's published his work. And this is basically where you can take the cells, you have the fate map here, and you can simulate this network as the as the cells are differentiating, dividing and differentiating, and then this network is forming. So this is the you give it an input data set. There's a default input data set, but you can give it different input data sets, and it'll derive the network for you. Really nice work. And of course, he's presented on this, or this is basically vibe coded, and it has a lot of nice features. And I think this is something that we can actually use, maybe for other things as well. I don't know, but this is a nice interface. And so yeah, we talked a little bit about this work, a little bit about finishing up GSOC. We had a little bit more with Morgan, where we talked a little bit about some of the things going on with respect to neuro AI. And then I did a feature here where I talked about putting things into production. So putting things into production is sort of the last step well, it's not the last step, but it's one of the last steps in a project. The last step, I guess, would be maintenance and maybe closing out a project. But the next to the last thing is putting things into production. So this means that you're going from your development phase, you're working out ideas, and then you're putting them out into the world. And so I covered this book here, Producing Open Source Software. This is a book by Carl Fogel, where there are different versions of it online. And it's basically about FOSS software, free and open source software, which we've talked about in the open source meetings this summer, and how those kinds of projects put software into production. So this book is a nice resource because it goes through sort of the idea of free and open source software and how it enables a lot of development, but then how it also enables a lot of production. Being able to license things in a certain way, being able to maintain a community, but most importantly, being able to get things out and into people's hands, and then fixing the things that need to be fixed. So this just talks about how to start a project, how to create a license, choose a license, how to engage in good communication skills in your team. And then there's a section on packaging, releasing, and daily development. So putting things out as a release and having a bunch of releases that come out, because of course, open source software just isn't a single release. Oftentimes you have many releases. And the whole point of open source software is that it's continually updated. So you release the software, you find bugs, you think of new features, and you want to release it again. But you don't want to start over and reinvent the wheel. You want to keep adding into that framework. And managing that is a task. You have to really kind of have a strategy for it, an intentional strategy. So this just talks a lot about how releases work and how you create releases in GitHub and how you create releases and keep track of them. And then that's what they talk about here, and then linking that to maintainers and maintaining the project. And then we talked about a few other papers. So we talked about this DevOps paper where, of course, putting things into production is about getting things out the door, but it's also about this connection between developers and operations people. And so there's this DevOps field that's probably about almost 20 years old now. But it's basically a way to sort of bridge the gap between development and implementing things in the world, not just putting them out into the world. So we talked a little bit about DevOps and how DevOps is this highly interdisciplinary field where you have this mix of philosophy and science. And a lot of DevOps really is about culture transformation. It's about automation, and it's about economics and understanding your market. So it's not just about like technical, putting out technical fires or making things more technically sound. It's really about managing teams. It's about changing teams. It's about finding your niche in the market, and it's about automating the right things. So that's the insight there. And then talking about the different tools you might use for DevOps or for putting things into production. This includes things like containerization, using version control, and the like. So that was our final open source meeting for the year. Okay, so that was those were our meetings from the last time we met here on Saturday to now. Okay, so we have a lot of things in the chat. So Barshan said, if anyone has any neuroscience programs that for me to publish my preprint, feel free to share on the Slack or Discord. Are you talking about preprint servers, or what are you talking about?
No, I mean, I can already search up the Microsoft CMT for the conferences coming up or something like that. Like I've not published a preprint before, so I'm just looking forward to like any kind of platform where I can look forward to if it matches my project, then
Okay,
I can just look into it and target it that way.
you're looking for CFPs, like for conferences, or?
I'm not sure yet, but yeah, but I'm looking forward to something to publish right now.
Yeah. Yeah, we'll have to think about how this fits into like the larger world of things.
Yeah, exactly.
Yeah.
Yeah.
So I guess the first step here would be to have like a preprint that shows the work and kind of thinking about. My guess is it would be like relevant to a lot of areas where people want to take maybe like cellular data and put it into networks and analyze it. So that could be
Yeah.
neuroscience, that could be computational biology, it could be network science or like machine learning, of course. But there are a whole bunch of
Yeah.
things that applies to you. So.
Also, it's explainable, so it also comes under XAI, I guess. Explainable AI. So
Yeah.
you can look into that also. That field is booming right now.
Yes.
That's
yeah,
all. If anyone has any ideas, that's what I wanted to ask. To,
Okay.
share. If anyone comes up with anything.
So we have Sarrah posted, this is the link to open source skills or OSS skills. This is something she came across in the Delhi alumni camp, which is this, I guess, the alumni of GSOC. A list of policies about AI generated content by different open source communities. This is the AI contribution policies. So this is a policy document, which we can use as a reference from when we build our own. So the guidelines are here. When other maintainers suggested to use to deal with anti-AI spam, outlining your policies in agents.md. So this is different than like a contributing.md, I guess, agents.md files, and then this coder, this site here for automated code review. Okay, and then PRs are not accepted if issues are not assigned to the contributor beforehand, including policy and enforce. Yeah, I mean, well, in the case of like GSOC, though, usually the whole premise is that you're picking an issue to solve. Or, I guess we could do it in any way, we can come up with our own kind of method for that.
Yeah, I mean, so these are just like what somebody had, but again, even in the even in GSOC, there are the pre-GSOC and during GSOC phases, right? So what, like, even pre-GSOC is when you have this like interest from a lot of contributors, and what mentors ideally like them to do is first talk to me about the issue you're picking up, unless it's, so again, this is where those tags come in. So some issues I think we can label as good first issues, which can be very simple, which is just for a contributor to show interest. But again, I feel like our org is not something that has a lot of those, right? Because ideally they're like small readme documentation changes or small bug fixes or something. But again, I mean, since we don't have many of those, that becomes difficult. But if there are any of the big issues, like for example, so this happened with my project last year, which was there were these 6 issues that I had created, which I had not labeled as good first issues because I had expected them to be solved during the course of the GSOC. But what a lot of contributors, kind of misinterpreted it as this is something we need to do now to prove that we are eligible. And they just started at it with like this is the first approach that comes to mind and let's do this. And when I was talking to the mentors over there, I mean, they face similar things, right? Even if it's not something that needs to be discussed, I mean, even if it's not something theoretical, it still needs to be kind of discussed with the mentor, right? So what they ideally like is at least for contributors to say I'm interested in this issue, please assign it to me. Mentors coming in and trying obviously within a day or two at the max to assign them, and then they know that only one person is assigned this issue and they can work on it. So that was something that some orgs followed, and then of course these were just kind of what I wanted to pick the brains of other mentors on what worked for them, and then we can kind of draft it for us, because again, as more of a research based org, I feel like we work different from a very software focused org, right?
Yeah, I
So,
think that's true. So the idea is that, yeah, you have your own tailored policy. I think in our case, yeah, we would have to kind of really think through how we assign issues, or how we sort of limit people to certain issues over others. And I mean, that already happens to some extent. You kind of put tags on the issues, but it's hard to know kind of in advance what that issue is going to look like when it gets solved. Because the idea is you say, here's an issue, uh, and then people will engage with the issue and then find out that it requires a lot more
yeah.
work. So it proliferates into other issues. But also, you do have people who want to show their technical skills, so they kind of spend a lot of energy producing something that may not be a good fit for the issue, or it might be a good fit for the issue. And so, that evaluation just, I guess, has to be done. I mean, the problem with GSOC too is that, like, it's more about, like, letting people kind of contribute. And so it's not like you're going and soliciting something for a very targeted task. Like if you were working in a more formal open source environment, you might assign a task to someone, and then if they'll try to hew very closely to that issue, and if they don't, then that's seen as kind of a problem, right? And then you try to bring them back into the scope of the task. But with GSOC, it's kind of like we're asking, and especially in our work, we're asking them to kind of solve a problem or come up with good solutions to the problem. And it's sort of an educational thing for them, so they get a chance to solve the problem without and sometimes they're going to make mistakes because they're not as seasoned as maybe in something you might otherwise give this issue to. You might give that to someone who's seasoned, who knows how to manage the task and knows the project pretty well. So that's the only thing that I wonder about. Like, how would you do that? How would you get, balance the sort of the imperatives of like education and kind of bringing people in from outside the org to work on things that aren't good first issues, with this need to sort of make sure that things stay within scope. Because I know that was our big problem last year. Is kind of like people will come in, and especially if they have AI tools, and they think they can easily solve a problem, and it's not as easy as you might think. So it's a learning experience for them, but it's also for us. It's a lot of work in wading through what they're contributing. So yeah, it's a it's an investment either way. There got to be better ways to do it though than just kind of throwing up an issue.
Yeah, for sure.
Yeah. No, this is not gonna be an easy problem to solve. I can't imagine. I mean, I'm sure a lot of orgs are struggling with it. Yeah, so I mean, yeah, I'm looking forward to kind of how we think through this, and if we can come up with some good guidelines, that's a good start. Yeah, and then Jess said, looking forward to the cybernetics work and the triads. And then Hussain is here, so we just mentioned Hussain, so welcome, Hussain. See, I summoned you. Do you want to give an update?
Oh, sure. I guess that's fine. So things are progressing quite nicely with my biggest project, which is ray-by-ray computed tomography, RBYRCT. As you all know, Dr. Richard Gordon passed away 2 months ago. I'm happy to share this website I made. Bradley, did you take a look at it? The memorial?
Yeah, I did see in the Slack. It's the archive, right?
Yep. Yeah, the archive.
Yeah.
Dr. Richard Gordon. I've been in touch with Natalie, Dick's widow, and she's been helping me with this. So I feel like I'm going crazy nowadays because she sent me this picture of him that you can see on Bradley's screen there, and I thought it was AI at first. There's something about this picture that seemed too artificial, but this is a real picture. Maybe it's probably touched up a bit, like post picture, but like it looks like there's quite a bit of touching up. Like maybe the background was added. I don't know, but like I thought this picture was AI at first, but no, that's a real picture of him. Sorry, for those of you who aren't on the same page, Dr. Richard Gordon, my colleague and collaborator for the past 2 or 3 years, he passed away from cancer two months ago. So this is a memorial that I put together, a digital archive. You can click through if you want, like research, publications at the top, yeah, everything. A lot of things are just placeholders right now. So, yep, I have his laptop with myself, and that's one thing I've been working on recently. But I'm carrying on, RBYRCT, carrying things on myself, reaching out to collaborators we've been working with previously, including people in Argentina. There's an engineer in Argentina that I've been working with closely, and a professor of computer science over in UK. His name is Mohammed Majid Al-Rifai. So these were like people that were working on ray-by-ray computed tomography with me and Dr. Gordon. And now that Dr. Gordon's passed away, I'm continuing things. The format looks like JoPro's site. Yep. Yeah. If it ain't broke, don't fix it. Like a lot of websites can be so. Yeah.
Well, yeah, we had discussed
Sorry.
We had discussed the idea of creating an archive because I pointed out that like a lot of the stuff that like the cyberneticists of what we talk about all the time in our cybernetics group, like W.R. Ashby, they do a lot of work in their lives, and they have all these. It's not just papers that are published, but it's notes and other types of things. But it's also sort of a way to account for all the work that was done in a lifetime, and so that was something we talked about. Yeah.
I have his laptop. It's in an acrylic case, so it can be nice and safe. I live in Indiana, so we get a lot of really extreme weather, like hot summers, cold winters. Even like acrylic cases for things are really useful. So from his laptop, I'm happy to upload content to my own personal, like private hard drives and keep things secure. Once again, communicating with Natalie and whatever we want to do with it. I had considered donating it to University of Manitoba, but I think I'd rather just archive and preserve things myself. So it was just personal memorabilia. That's really exciting stuff too. So yeah.
So this week I was busy at the Artificial Life 2026 conference, so it was a pretty big deal. I'll talk about the presentations that I gave there, and so let's get started. So Artificial Life 2026, This was hosted by the University of Waterloo in Ontario, Canada. So this is the campus of Waterloo. And it's a tech college. It's kind of like Stanford or University of Illinois Urbana-Champaign, or even something like MIT, where they produce a lot of people, a lot of computer programmers, a lot of people in engineering. And it's one of it's the main engineering university in Canada. So they produce a lot of programmers and other people like that for tech companies. And we'll talk about a tech company that they kind of gave a shout out to during the conference in a bit here. So the conference was on, it's a city, Kitchener-Waterloo. Waterloo is where this campus is, University of Waterloo. There's also Wilfrid Laurier University, which is right next door. I don't know if it's in Kitchener or Waterloo, but it's basically a sister institution. And so that brings up the way this conference was hosted. So it was hosted virtually, but also physically in Kitchener-Waterloo. And they had this, it wasn't just Alife, it was actually a joint meeting between Alife and the AAMCS, which is a mathematics conference. So they had these joint sessions, they had individual sessions, and it kind of went between the University of Waterloo and the Wilfrid Laurier University campus. So these buildings in these different campuses. And so, you know, there was a lot of content that was related to artificial life, but there were also a lot of different sessions that related to like applied mathematics and modeling and computation science and things like that. So it's nice that they had these joint sessions, this joint interest, and it did deviate a bit from like the more traditional artificial life sessions, especially some of the keynotes. And I think it was pretty good. I thought it was a pretty good conference. Pretty long it lasted. You know, they had sessions from Monday to Friday. And it was a mix of different workshops and different main sessions. And, you know, so there were a lot of things on collective behavior. There were a lot of things on cellular automata. There were a lot of things on genetic algorithms. And a lot of things on kind of machine learning and integrating machine learning with all of that. So there's some really interesting talks. And, you know, even things like active inference were represented there. So it was a very nice conference. And I'm going to give a more detailed presentation a little bit later on. So we can kind of think about, and you know, I have to digest everything. I was actually keeping a slideshow. It's a different version of this slideshow where I was taking notes and, you know, kind of making slides as the talks were going on and thinking about next year, thinking about things we can take away from the conference, even doing some agentive coding during the day to kind of work out some ideas. So it was very, very exciting and fertile time. On the first day, Monday, they had some sessions, and at the end of Monday, they had a showing of this film. It's called Blackberry, and there's still a company in Kitchener-Waterloo called Research in Motion, and they were actually the people who created the BlackBerry. So if you're old enough to remember, the BlackBerry was one of the big PDA devices, or personal digital assistant devices. And they started building those in the late 90s. And they continued to be popular throughout the 2000s and really up until the iPhone came out. So before the iPhone came out, the BlackBerry was the dominant thing that people used for that sort of thing. And so they talked about Research in Motion and how that came to be. And this is a film. It's kind of like a drama, but also a comedy, kind of a dramedy about the founding of the company and about some of the shenanigans involved in it. So, you know, it was Glenn Howerton was in it, so it wasn't that serious. But yeah, it was a nice little social event there. I was responsible for producing 2 artifacts for the conference. there's this paper, Phylogenetically Mixed Architectures, the Development and Evolution of Agentive Complexity. This is something that I presented in this Saturday meeting before, and I'd worked on. This is agentive coding of a pipeline that has a bunch of different computational models in it that allows you to build an agent population or generate that agent population, evolve different shape combinations, and then put together different components into a common framework. So I'll talk about that in a minute, the rationale for that. But it is related to what we were doing with developmental Brainberg vehicles, and it is sort of like a takeoff on that, but it's also relevant to other different projects that we're doing. So I'm kind of excited about it. It's not, it's a kind of a first pass approximation at what this pipeline could be, but just kind of laying out the different methods that you could use and, how effective they are. And then there's this whole agentive coding aspect where you're asking the model, or you're asking your agent model to produce code to implement a model. You're working through that model, you're putting it into the pipeline, you're evaluating what the model is doing, and then you're kind of reporting that out. So it's kind of a different way of doing modeling and simulation. And so I have some videos on the YouTube channel. I have an overview of the poster presentation, which is like 20 minutes long, and a more in-depth talk where I have slides, and that's about an hour long. So I think I've kind of beaten that to death in terms of the description. There's also a conference paper that was in the proceedings on this. So that's the formal write-up. Then I also presented at the Life Dev workshop. So there, like I said, there were poster presentations, there were topical session presentations, and then there were workshops that different people hosted. One of which was this Life Dev workshop. This was on Tuesday, and I presented ensemble models of early life. So this is work that is, so this was something that Richard Gordon was interested in. And we did a paper on this back in 2024 with Bashir Ahmad. And then Richard and Hussain did a paper on early life as well in 2026. I think it was this year where they published it. So I presented on all that work sort of in a very superficial manner because it was like I had 10 minutes to do it. But people got to see that work. So that was the presentation there.
Yep, yeah. So that was our paper on cold selective topological bias of origins of life. In which we performed. I even did some GPU simulations on my video PC. That was really exciting, and I had to explain to Dr. Gordon what a GPU was. That was
yeah. Yeah. Well, anyways, I think that like putting that together in its totality is really interesting. Seeing where. Hold on. So I think putting that together in its totality is really interesting because I think there's a lot of stuff that could be done in the future on that. So the first thing, so this paper here, this first one, Phylogenetically Mixed Architectures, basically this is the idea that you have agents that you can design kind of the primitives for. So like for a Brainberg vehicle, it would be the sensors, the effectors, the connections between sensors, effectors, the interneurons. So sometimes you have interneuronal points within the agent, and then the agent body parts. And the idea is you have this group of parts that you generate through some model. Another model will evaluate the viable combinations of those. And then you go through to a genetic algorithm, and you have the genetic algorithm select the most viable, not just the most viable phenotypes, but the most viable phenotypes that can build sort of an improving lineage. So, if you have a bunch of vehicles that are kind of related through this common ancestry of parts, then you have these lineages that get built. And then at the end of that process, you can take the things that are selected for, and you have different criteria for selection. And you can then put them together in different sort of mosaic architectures. So the shorthand of this is if I had, say, like the tree of life, and I had different taxa in the tree of life. Here we have nematodes, fruit flies, mouse, and a primate. And so we have that, and they're pretty phylogenetically distant. And if we want to take like their bodies and brains and their behaviors, it's a wide range of behaviors. But let's say we wanted to create an agent that combines sort of the architecture or the behaviors of a fruit fly, a nematode, a mouse. So all those three taxa, and remember they're widely divergent in terms of their specializations, in terms of their neural architectures, in terms of their behaviors. But let's say if we wanted to create an agent that was maybe specialized in these different types of specialized behaviors, but also you were able to sort of build an all-purpose agent that could do all these things in one agent. And so the idea would be that we would evolve we'd evolve a bunch of agents, we'd put them together, we'd identify lineages, and then we'd take the lineages and we'd combine them into a single architecture. So that's what we're doing. We're evolving things from a common ancestor, a simple motif, and then we're stitching phylogenetically distant motifs together. And this is the pipeline. So to do this, I propose that we use this sort of process where we create a bunch of variation. So we can do this in a couple of ways. We can do this using a reservoir network, or we can use this using a diffusion process. And of course, a diffusion process in the sense of machine learning diffusion, not physics diffusion per se. And so we have maybe something like Bratenberg-Violical's parts list, or in the paper I also used a set of simple shapes to demonstrate the idea. And so this is just kind of a first pass. If we were going to actually put this into production, we might create a more formal input data set of components of different types of sensory motor embodied agents. And then we put them into these different, put them into this pipeline and end up with some lineages of these agents, first of all, and then being able to stitch together architectures from the outcomes of generating variation and then evolving it using
Hey Bradley, could you explain? Could you just explain what exactly? Could you just explain what exactly a stitch is?
Oh, I just mean like combining them. You'll see what I mean later with the. We actually use hypergraphs for this, but basically combining them into the same agent. So
Okay.
stitching is a little vague in the sense I'm using a kind of a colloquial term, but basically
I'm familiar with terms like recombination, convergence, evolution, but I don't think that's exactly what you're talking about.
No, it's more like just kind of putting it in the same functional context.
Okay.
Yeah. So the first part here is where we take the input data, we put it into either a reservoir network or a diffusion process, and it turns out that each of these types of model, are good for different types of input data. So, if you have very highly variable input data or sort of input data that is ill-defined in terms of its function, then a reservoir network is good. If not, then you can use a diffusion process. It really is up to the user how they want to implement this. And then, of course, once you enter your data set into these networks, you end up with this time series R of T, which then is used as input for this GAN, which is a model that has both a generator and a discriminator. So you basically create a latent space. You produce candidate latents from this time series that's generated either from the reservoir network or the diffusion process. You then have a discriminator that sort of evaluates the different latents, and it generates shapes that are candidates for a genetic algorithm or a selection function. So for the diffusion process, we have forward and reverse diffusion, which means that we take things, we embed them in noise, and then we try to recover them from noise. And it's supposed to create a more robust training process for the algorithm. In a reservoir network, we're simply putting things into this network, and we're reporting out the current state of the network, and we're producing a time series. And then we're plugging things into this GAN where we generate a latent space. We take things from the latent space that are viable, and then we hand it off to this genetic algorithm that has a selection criterion, 2 fitness functions, one of them being select the things that are most similar to one another and create a lineage. Another is find things that are, sort of have a creativity criterion where you find things that are novel and then create a lineage from that. And then finally, we can do things like we can create, this figure isn't even in here for some reason. It's not showing up. But this is where we can create these dendrograms that are these phylogenies that basically show the lineages and their novelty score. And so we can take some of the nodes from these lineages and put them together in a hypergraph, which is where we basically arrange these different phenotypes that are generated from the dendrogram and put them together in the same functional context. Now, what I was going to show you here was, and it's not showing up for some reason, but it's an image of the of different Bratenberg vehicles and how those were evolved and how those form lineages, and then how those lineages were selected and put into a hypergraph. Okay, so that was a little bit about that. And then again, there's a presentation. There are 2 presentations on the YouTube channel, so I'll let you look at those. And then, of course, this is the early life work. So we focused on 2 things. The first was compartmentalization, so which is where you have this idea of concentrating things into containers, which is thought to be one of the hallmarks of early life. So a lot of early life work is done in vesicles. And so, the idea is that you have these vesicles where biochemical reactions can happen. And the idea is if you have, vesicles are sort of the earliest cells, that things, you have reactions that have to occur in a confined space in order for them to be protected from the environment, in order for them to sort of be concentrated in a meaningful way. And then, you can have something that resembles a cell. And then, what people will do is they'll create these vesicles experimentally, which are basically lipid membranes with things inside them, create something that will kickstart reactions. And then, eventually you can have cells and you have vesicles that can divide and reproduce. And then that's basically the start of life. So compartmentalization is an important part of early life. And also evolvability. So it's like, how do you put the parts of these very simple components together to form complex phenotypes? Okay, so, so then that's what the early life presentation was on. This was the initial work that Richard Gordon, myself, and Bashir Ahmad did in 2024. This is where we did a number of simulations on this idea of compartmentalization, having these vesicles where things kind of moved in and out of the vesicles, and then reporting on sort of what happens when, with vesicles of different sizes and of different densities of mixtures within them. And so that was the paper, I talked a little bit about that paper and some of the results. And then this is work that Hussain and Richard Gordon did. And this is where they kind of, instead of assuming that this was sort of a homogeneous membrane, then you have these more complex membranes that are these trapezoids of the polar head and hydrophobic tail. So you're adding in biological detail, you're adding in this heterogeneity, and things that disrupt importantly, things that disrupt symmetry and introduce topological variation. And so this is just kind of thinking through this aspect of the work. There's also, of course, this work on evolvability, which is tied to the phylogenetically mixed architectures in the sense that you're creating from a parts list these lineages, these phylogenies of things. And the idea is like, can we create things from a parts list that are viable through some simple recombination process? And can we basically kickstart some sort of phylogeny from that? So yeah, I think the work was, pretty, it's like at any conference you present, I didn't get a lot of feedback, but it's like you continue to work from what you presented. Okay, Hussain.
Yeah, I had a question on that last slide that you had, with the 2 orange dots. What exactly were those?
Which slide was that?
This one, you have it right there.
Okay.
Compartmentalization. What are the orange?
Oh, this is supposed to be a sky. So this is one part of the talk where in the original paper, the first paper, we did this experiment with day-night cycles. And so you'd have like the day and then the night, and then the idea was that for the vesicles, you had these membrane pores that would open and close with day and night. And so you would have an opportunity for the components to escape and an opportunity for the components to diffuse into the membrane. And so when the membrane pores were closed, you could have reactions if the day-night cycle were longer, say. And then when the day-night cycle switched, like I don't remember if it was day or night, when the pores were open, things would diffuse out. So you'd have less of a chance for reactions. And so that was what this was referring to as a sort of day-night cycle in an early planetary environment. It just had this graphic that didn't really mean anything.
It's like sunlight, then nighttime, then sunlight again. Okay.
Yeah. I just used that theme throughout the talk, wasn't it?
Yeah. I'm happy to share my updates on PCC if there's time for it.
Yeah. Would you like to do that now, or? Yeah.
No, I can do it now, unless there's something else we need to talk about, or like if there's something.
Well, Morgan's going to give an update, but yeah.
And I
We'll do
also do need to.
Okay, we'll go. We'll let the others. I think they can.
Okay, well, yeah. Who wants to go first, Morgan or Sarrah?
Morgan, you can go first. No. Okay, fine. Okay, so yeah, 2 updates from my side. One is regarding what Jesse said again for the fall. So, I mean, what I understood was we were trying to see if there were projects that we could take up, maybe even stir up some interest in the same. And, just, yeah. So for that, I mean, I do think the kind of the extension of my GSOC 24 project that I had planned this year for 26, that we also had quite some interest on. And I mean, so because of those discussions with all those contributors and all of that kind of being documented in those GitHub issues as well, I do think we now have quite a clear roadmap on where we want to go. So, I mean, that is a decision we can take, I guess, on whether we want to kind of sorry, just a second. Yeah, sorry. I just wanted to say on whether we want to kind of keep that for GSOC 27, or I do feel like if we gather enough interest, that is something that I could mentor kind of, even if it's during the fall season, instead of waiting for the summer, where we could have some enhancements on that we had discussed already for 26. be done. So yeah, that chess is the what I put up in the message as well. So it's mostly software related. It's technical enhancement. So I don't know if that is exactly what you were looking for, but
Well, yeah, I mean, and is this when you said put in the message? Did you mean in Slack or?
in the Slack, yeah, this is what I'm talking about, the Slack thread. When you talked about things for the fall, should I print it out?
Oh, I see. Yeah. Okay. Yeah. I mean, it really depends, and I don't know. I defer to Bradley about this too, but like, if it's something that you want to work on during the fall, like, and would want us to work on either with you or like center more, like, absolutely. Like, if it's you don't have to wait until summer to work on it if it's something you want to do. And if you want, you can work on it just yourself, or if you want there to be more like, hey, here's something that we're going to try to do and center a bit more.
Okay,
That's
the
like
audio did cut out.
yeah.
Okay. Yeah,
think
what
the
I mean,
advantage
so
of do-
like, sorry,
the
Bradley, go ahead.
advantage of doing this in the fall is where you don't have the pressure of GSOC, so people can work on it. You can kind of work out some of the things about the issues in that too. So.
Yeah, so I think then for fall we take up the guardrails and the issues and all of that, and because this is something that could easily be worked on by a new contributor or a student as well.
Yeah.
So I think we can defer this to summer then maybe. I wasn't sure what call for involvement meant. I mean, if it was us working or if we wanted something that would be appealing to first time contributors. So this I would definitely classify as something that's more appealing to first time contributors. So I mean, we can try to maybe then take it up in the summer and try to work on the guardrails and how we can structure our repository more in the fall. So I will try to look into that as well, the links and everything I sent today, and what kind of policies we can make, all of that.
Yeah, and in general about that, like in terms of call for a moment or what you want to do, like we can talk about it more here or offline or in Slack or whatever. But like however you want to, the call for a moment in general, because it seems to raise a lot of questions, is basically like an open call. Like if people want to say, hey, here's a project that you can take some leadership in during the fall, like it's sort of just saying, let's build it out, and if you want to do it or like get help, if you want someone to join the projects or whatever, like let's formally, it's sort of it's administratively sort of working with you to do that, because a lot of times the things will happen or they'll fall off the map and there'll be whatever, then you go, I'm interested in this stuff, but it's like this is a very intentional overt gesture of Bradley and I are open to building out or supporting, offering administrative support for the project if you want to do the leadership. The thing we can't supply is the leadership and the desire to make the thing happen. That's on you, to the level you want to do it. But like outside of that, we have the means to, we're in this sort of, it is the time to let people know you want to work
kind of expand.
Yeah, expand or make it a lot of this stuff. We in this room and in this, if you've been here with us, you know what Sarrah means. You know what Ashu did. You know what Barshan did. Like, you know what the people have been working on this summer or on this thing or in that stuff. But anybody outside of this room probably has no idea. So it's the work of creating a organizational structure or space that other people can see it and say, okay, oh yeah, Sarrah has this project. Oh, what is it? Where do I look at it? How can I do it? And maybe we can have like a small, like a not every project requires to have an internship or a call for other people to work on it. But if you do want that, we're like, well, we will help you do that. That's kind of what I was getting at with all those things.
Okay. Yeah, okay, I get it. Yeah, okay, then I mean, so again, the reason I I mean, so just from my perspective, I was thinking of kind of mention this to Bradley as well, but I'm going to try to be applying for a master's in fall 27. So
Yeah.
the application process for that would kind of start, now for me
Yeah.
with like the test of English as a foreign language, and then everything else just will like one by one. After that, my GRE is done, so that I'm good with. But everything else is kind of to do for me. So yeah, again, I mean, I'm not just sure about how much time I will have. So that is why I felt like leadership is something I could have. But yeah, I mean, individual contribution, especially if you're also trying to do the guardrails and everything. But I can still look at it. What I can do, I guess, is so I do have some connections from my college, right? So let me kind of see if there would be, maybe students who would kind of be interested in contributing to this. And then if
Yeah.
we do have interest, and then, I could then definitely take up leadership and mentorship in a sense.
Yeah, and like you can obviously just, I know you know this, but like you don't need to do all that extra stuff too. We're just offering it
Mm.
as like a thing. So whatever form and whatever whatever capacity you have, it's just like I think that'd be, if you have the means to do the other stuff, that's great too. And also, like, I'm sure we're all happy to, good luck on the master's application anytime you want to talk about that. You
Yes.
say you were applying to specific places like outside
I
of?
have not yet. Yeah, I mean, it will definitely be outside of India.
Yeah.
And I do want US to be a major focus. I might apply somewhere else as well. I mean, I'm still a little bit on the research side of everything. But yeah, I mean, I will, keep you all posted, and also
Yeah.
I think keep coming to you all for advice a bit as well. But
Sounds
yeah,
good.
not yet fully decided on everything. But I mean, I will definitely be applying to some US schools for sure.
Okay. Well, definitely stay in touch about all of that, and I'm happy to see you do that, and also like I think you bring up a lot of things, and even the email, which I won't. I'll say more about that too, but like
Hmm.
I think you've got a lot of good things that I hope you keep going towards.
Yeah.
So,
Yeah. Same. Uh, yeah. Okay. So that's one thing. I think, yeah, just let me float out and see if there's interest, and then I'll get back to you, and maybe offline, or just I'll ping you on Slack, and we can see about about the fall, about trying to do the LM project in fall. Yeah, okay, just give me like 2 minutes. Morgan, if you want to go with a short update, I will just need 2 minutes to try to present for the next thing. I mean, I know you wanted to speak, so if you're ready now.
I can just say a few things. So one, can you hear me okay? Just because.
Oh yeah.
Okay. Yeah. I'm running Fedora on an old iMac.
Okay.
And yeah, so just working through a few glitches. So yeah, this week was the opening of the lab space that you see behind me. So this is the Other Minds lab, and let me just. I mean, this is just a temporary website describing Other Minds, and this is together with two others, Caleb and Skylar. Caleb is a postdoc at starting a postdoc at JPL in kind of end of September, and so he's a planetary geologist, but is also interested in SETI and, of course, astrobiology. And Skylar is the one who approached me about the supporting kind of the neuro program in terms of both equipment and research mentorship, and in particular, and for both of these kinds of projects, also getting access to supercomputing resources. So like the Neuroscience Gateway being the kind of the neuro version of this, and then Open Science Grid and Globus, et cetera, those kinds of resources that that I certainly became aware of through kind of Nano Hub and material science discovery. Both cases, yeah, so access to kind of GPUs, compute to work on very large data sets, right? So astronomy is actually, I think, a great field to really learn from, especially around the topic of physics-informed neural networks, how to accelerate both data processing as well as simulations, because they literally work with astronomical amounts of data. Just to like related to that, new paper, or at least new to me, is this from Karniadakis. Yeah, never actually heard it out loud. But this comes back to this issue of so I don't know if you guys remember talking about this particular researcher who's kind of credited with starting PINs and but multi-agent development for these kinds of algorithmic development. Yeah, and this is anyway. I've posted on this. I forget if I've dropped this in Slack already, but like really interesting topic that again, I think we're going to be able to have some nice data sets from other minds lab work that will be really interesting to apply these kinds of techniques as examples, or kind of to prototype things. Yeah. Sort of related, or at least another benchmark is Steve Brunton, who's the very popular videos on PDEs, optimization, and other topics, released this Hydrogym, which again is just a nice way for us to test out some of these developments that we're kind of using agentic tools to develop, but really important to have some evaluation for these. And yeah, that's those are the big updates here. Sorry, let me turn that off again. There's neuroimaging, and still share the link for yes, Jess, which for other minds. Okay, it is a placeholder. I'd like it to be more like the new NeuroTech site, where it's just like we're doing more. The website is a better is a resource, So, but what I love, Bradley, and certainly what I mentioned was that at our open house on Tuesday evening, that I think artificial life, the kind of like introspection work in large language models, algorithmic information theory for, learning about structure of messages, are all under the same lab portfolio, or lab mission, and that also includes origin of life, or like at least some. I talked a little bit about the Build a Cell seminar, which has been really valuable in terms of getting, it's just this wonderful seminar series every Monday to learn about, protocells and membrane physics and, all sorts of replication systems, that, which is led by Kate Adamala, and who had the recent spud cell paper. So so I've got a new donation of another Opentrons and some and actually some really nice factory arms, some new factory arms, which I thought, again, well, we've also been doing the last prep work for the how to biomanufacture almost anything. And even though it's definitely got a bit of a practical focus, I like that the node at William and Mary, the professor there is coming up with a practical lab experiment on biofilms that, again, I think some of these experiments are actually, with slight modifications, can actually really be relevant to the same kind of work, the same kind of origin of life, or interesting physics properties that like CompuCell 3D people kind of care about, for thinking about interactions and yeah. That was our week.
Yeah, that's great. That sounds great. Thank you, Morgan. Yeah, a lot of the things we can kind of figure out what those synergies are. Like you mentioned, there are a lot of potential areas to move forward on. So, Sarah, are you ready to? You were going to present something.
Yes.
Okay.
So yeah, what I wanted to present was so that's what the email was also about. So I was trying to convert my 2024 GSOC project into a paper, and I found a workshop in NeuroSim. So I found this workshop in NeuroSim that I feel like kind of encapsulates exactly what we were trying to do, which is a social agent, the workshop in large language models for social reasoning and simulation. It's going to be held in December, but the call for papers deadline is August 25th. So I was working on this the past, I would say around 2 weeks. So yeah, this is basically, the workshop is on, the themes are on social reasoning and cognition, and how like there is genuine reasoning versus just prompting artifacts. So prompting artifacts is just when you tell LLMs to do something and they kind of do it. So they do want people who kind of build LLM based social agents, but then do it with some kind of grounding. So that is what I feel ours is, right? Because of the softwares that I've integrated where they actually try to solve code, where they put in pull requests. So we have like actual basis for our agents versus just telling them to imagine themselves as someone. So this also comes in about in this theme where it's how valid is that simulation, how valid are those LMs as proxies, what are those standards. So I mean, as won't be something that kind of presents those standards, but we would say that the fact that this code works is one thing where it could act as a proxy for a developer. And I'll take you all through the paper as well, where you'll understand. And then these were their basic topics. So I do feel like this is what goes the best, which is agent-based social simulation using LLMs, how they coordinate, how they cooperate, what is their collective action. So we do have a lot of these themes when I had all of my work on how contributors discuss amongst themselves versus how when they submit a pull request, how a maintainer reviews it, and how that how that kind of affects the contributor on them. So yeah, this is about the conference, and then I do have a very, very rough draft of what I would like my paper to be. So I like it to be like, I think this one of these like short papers itself, because again, most of my this was about how I built the LLAMAOSC software. And yeah, I mean, this is just in a Google Docs for now because I did want to, just put it up here. And then once I have all of your feedback and comments and some changes also that I wanted to try to make, once I have all of that, I can convert it into LaTeX and continue from there. But yeah, this is so. If like anything so far, or I can just go through the paper as well once. What I've drafted. Okay. Yeah, so I'll just continue. So yeah, I mean, so LLAMAOSC is what I had named my software, and I think for the paper I would like it to say that it's a grounded cybernetic agent-based model for open source sustainability simulation. The reason is that the reason we're doing this project is sustainability of open source communities is threatened by escalating rates of contributor burnout. And agent-based models that utilize large language models offer a good approach to these dynamics. I've also addressed this in literature review where I did see some papers that kind of tried to do the same, have agent-based models utilizing LLMs for different social dynamics, not this particular one. But most of them are these like textual simulations where you are an agent. Imagine you are an agent in this situation. How would you react? How would you do it? There are a few papers that also try to make the agent solve something mathematical or something that gets reviewed to kind of bring them as close to human proxies as possible. So that's what I say here, that sometimes these textual simulations do suffer from prompting artifacts. So we introduced LLAMAOSC, which is the LLM-driven agent-based model for open source community sustainability, which is an ABM framework bridging generative social simulation with deterministic software engineering, which we do by integrating these LLM agents with the autocode rover software in isolated Docker environments where they each have the ability to generate and test actual diff patches on real GitHub issues. And the effect of how these patches are generated and tested and created affects their internal motivation, which carries the whole simulation. Again, so during my time, I had empirically tested two different topologies, two different governance models. Authoritarian assignment model, where there is one like central maintainer who's kind of looking at which issue should be assigned to who, reviewing everything and doing everything, versus a decentralized peer bidding model, where agents come up with their own solutions bid amongst each other, and based on the discussion, those bids, mathematical bids, are created, and the agent who wins the bid kind of gets to work on the issue. And I did so what I said I was working on in the past 2 weeks. So I'll share it, but I did run some around 30 odd simulations on the software in different varying levels of difficulty projects. Everything from building like a basic calculator CLI app to like trying to build a GUI paint app. And what I saw was among these two governance topologies, the decentralized governance generates like the networks and the motivation decay and everything that it generates. It kind of is better compared to the authoritarian topologies, which proves that everything that is structurally more resilient. I think there's some mistake in writing this line, but what I wanted to say was proving that decentralized is structurally more resilient. This line is something I hope to remove because among those 30 odd simulations that I ran, some things that I ran for the very very hard ones, very hard problems, the autocode rover path generation kind of failed for a lot of those. The reason being I was using a basic Llama 3 LLM model. So because of that, I do think, it does not have that good of a capability. So I will just try to take the next day or two and see if it's possible to get better results, or maybe then just keep it and say that I'm using a older model that did not kind of work that well on the more difficult issues. We don't have very accurate data for that. Yeah, so coming to some, this is something that was from previous research, where basic research on real life has found that there is a very high dropout rate for new developers. 50% of newcomers just make a single contribution and abandon an OSS project. And about 45% of contributors eventually suffer from burnout and they just kind of disengage and such. So to like predict the health of these communities, instead of trying to just do analytics on the existing platforms, where you just try to see how many lines of code has each individual contributor committed, we say that we have gone towards prospective agent based models. The majority of the current multi-agent simulations operate as pure textual role play. So it is just via probabilistic language generation. There is no environmental feedback that they're getting back. It is just one agent talking to each other, which is where prompting artifacts comes in and what we want to not have. So instead of just having a prompt instructing it to do so, we are trying to bridge this simulation to reality gap by grounding the social dynamics with a deterministic software engineering engine, which is the kind of code space that I would say I've created, where we take issues from GitHub, we take our existing GitHub repository and we use autocode row. And using this, we evaluate two distinct models. And we try to measure the simulated motivation decay against the human baselines that we get from those earlier papers. And we demonstrate that the decentralized peer-regulated governance preserves integrity and mitigates burnout to a certain extent compared to authoritarian models. And this is just some related work and all the references that I've taken. So some agent frameworks that I looked at to understand how LLM based agent based models work, and autocode rover, of course, that I used within my project as a software. And next, some papers that I referred to understand these governance models. So understanding of these authoritarian versus decentralized models, and also how like traditional ABMs used to use reinforcement learning in a way, and how I could try to do that with LLMs. And of course, the paper that we're using as the human baseline for motivation decay. And so we have like a baseline of 50 to 60%, and we want to see how close we can reach to that to, kind of prove that RLMs are good proxies. And then the methodology, which is what I created. So yeah, coming to here. This is kind of from my final blog as well, which kind of just explains this diagram on how LLAMAOSC works internally, about the environment, about how I've used GitHub repositories and integrated autocode rover, about how I have created these issues ranging from like good first or earthshot issues to expert required or march issues, and introducing metrics such as code quality, which is measured and updated at each time step by a reviewer agent, and we can kind of try to visualize its trend to understand more. And then what do the agents have? So they are coding ability, and each agent has a persona as well, so their role description, which comes with a unique backstory, which affects their initial motivation level and their behavior that they have during these GitHub discussions. And then the agent variables, which is their internal states, which also we try to graph and plot, which is their experience level, which goes from 1 to 5, or their motivation level, which is influenced by both this backstory role description as well as the bid acceptance rejection, the success in assigned issues, and the code quality reviews of generated code requests. All of these is like environmental feedback that affects this internal state of the agent. And yeah, it's deterministic. All of these things will affect it instead of just just textual things. And I tried to run these simulations from like, so I ran 10 simulations each to get an average understanding. So the first, like the easiest one would be like a to-do list project, to something like a GUI paint project kind of task that I asked it to work on. And this is explaining the governance models, and what we observe. So the maintainer agent, when it manages and allocates tasks after evaluating contributor proposals, it kind of forms a very rigid network, which will create communication bottleneck, because all contributor agents need to talk to the maintainer agent and wait for it to make a decision. Whereas in the decentralized model, we have this whole bid making process where it empowers these contributors to bid on tasks based on their own suitability. They self evaluate their experience level and check whether they are eligible for something or no, and their internal motivation. And based on that, they bid mathematically combined with a textual representation as well. And then next is just how these motivation functions change. So how at the next time step, the motivation function will be the previous time steps with a decay on what happened if they did not get something they bidded for. So there'll be a decay in proportion to that. Otherwise, if they do generate a valid dispatch, it will increase. So there will be a increase in that. Or if the tests fail, then it will decrease. And then the final, and what would affect the motivation the most, again I think this is a mistake, this should be times 50. But yeah, the final code quality score will say that it is about what is your code quality, so a function of the quality. If it is very less, it will be negative, it will apply a penalization. Otherwise, it will be a positive multiplier. and a variable as well that was introduced to kind of simulate human mood variability, where sometimes the motivation could change randomly as well, based on some agent just not feeling like they want to continue even though everything is going good for them. So for that we introduced a random stochastic variable. And the next is the results that I had on my this. So yeah, so the first thing that we noticed was the decentralized model required more longer and more token based phase for the discussion where they were deciding on what to do, because for the authoritarian model each agent comes up with, I will solve this issue like this, I will solve this issue like this, and the maintainer just picks the best one amongst them and says yes, it's assigned to you, you solve it. Whereas in the peer bidding model, sometimes they contradict each other as well. They say that, yeah, you are more experienced, you should solve this issue, but what you are suggesting is overkill. And then the others agree and say, yes, let's let this agent solve it and such. Next, I address that on the high ones, the model struggled under this like technical ceiling of both autocode rover and it using the llama 3 model. So sometimes for the really really tricky bugs it just could not create anything. So we were able to see the differences also using this, and I would hope that I will try to run some simulations with a higher model that would kind of eliminate us having this ceiling in the first place. This again is exactly what I talked about, the authoritarian, this maintainer having a lot of load of evaluating everything. So these are those hub graphs where over here, like each contributor just trying to talk to maintainers for each issue. Whereas in the peer bidding model, they kind of just talk to each other in those. This is about, these graphs are based on the original GitHub discussions where they are trying to understand who can solve what. And of course, even in decentralized, for code quality review or PR review, the maintainers come in. But in authoritarian, the maintainers are also points of contact for the initial ones as well. So the decentralized run shows volunteerism and conformity. So for this, I have added some. So these are like snippets from the actual discussion that these agents did. So this would be something where, agent which has a good level of experience says that I propose introducing this dictionary that maps these names to their values. And so another agent with lower experience actually comes and says that, yeah, I agree, but I think we can actually simplify this. We don't need multiple dictionaries. We can just use one to store both the line coordinates and colors. And based on this, the both these contributors then give bids, and even though contributor 1 is selected, because this is put in the discussion, it will take this into consideration as well when it's actually solving this issue. So it says that this has like an advantage, right? Even the less experienced agent, even though it is not contributing to the pull request, it is refining the approach prior to bidding, and it is kind of ensuring good allocation as well. The next is this, where we try to compare what our agents did with the empirical human baselines. So this is the graph that I kind of ended up creating as an average of these, of all of these uh, simulations, where you know for in authoritarian, more agents dropped below this critical continuation threshold, and the reason is also explained in this, where because this contributor was kind of selected, and it was not able to solve it correctly, so after its evaluation, its motivation dropped by a huge number. Whereas the decentralized model, it says that it has a little bit more resilience. So, and then of course, I also agree that the mass shot issue kind of skewed this data a bit. So I want to try to generate all these graphs once again. But yeah, so that is kind of the two kind of metrics that I wanted to put up, which was one was these motivation decays and the other being the communication models. And yeah, I guess one of the main this is the fact that we have something that actively has code creation and kind of if gives feedback based on that, and how we compare the decentralized versus authoritarian models and what differences and similarities we observe. So that is what I've tried to base my paper across. And yeah, I'm open to any and all feedback on
Yeah.
both. I mean, what I should address, if there's anything I addressed wrong, any basic feedback about the structure of the paper as well, and so on and so forth.
Well, I mean, it looks good. Why don't we reserve the like comments on it to Slack and that, so we can.
Yeah, sure.
Yeah.
I will. Yeah, I think
Well,
I
thank
just
you.
dropped in the. Yeah, I
Yeah,
dropped
that's
in
the
the link of
workshop.
the
Yeah.
workshop, and I'll also drop in a link of the paper so anybody can just kind of come up with comments as well. I do have to do some work to um,
Yeah.
fix a few things as well in it, empirical data wise as well. But yeah, sure.
It looks like you've
Thank
made
you
pretty
very
good
much.
progress on it. Yeah. Thank
Yeah, yeah, I did for the past few weeks. Since I found this workshop, it was some motivation to that there is like-minded people who are kind of doing similar things with LLMs and social dynamics and such. So yeah.
you. Yeah.
I'll try and find the paper. We just did. So the other thing that we did Tuesday night was the CogSci reading group on the reasoning models generate societies of thought, and in the replication work that I was doing for they didn't release code, and as usual, and but in replicating it and thinking more about some like they were really trying to make this point about the diversity of perspectives in this particular. And one thing, and I'll try and find it. I'll try and find it right now, but maybe I'll just drop it in the Slack. But it was kind of like an entropy measure to get at the diversity of agents, contributions, and especially if you're just when you have a bunch of agents, but they're all basically using the same model. Like, how do you get actual diversity? And it of course is a paper that I got from Elvis at Dare. I think most of my LLM papers at this point come from Elvis, or But I'll try and find that paper because I think that's interesting, and I've certainly I've played with your repo, and in doing experiments, and that might be something to link to this. But like the workshop looks really interesting.
Yeah, sure. Do feel free to reach out to me on Slack as well with any feedback or comments you have. And yeah, thanks. That's all from my side. Thanks a lot for listening.
Thank you. Yeah. I don't know. Hussain is. Does he want to present or?
Hi, yeah, this has been fine. I appreciate the updates from the others do we have much more time? Because I think are we going overtime right now or
We can go for like 10 more minutes. That's fine.
okay. Yeah. Yeah, so a lot of my more recent work on PCC, on pressure chaos control, for those of you who are unfamiliar, so this is a new research program I'm developing, Pressure Control Chaos, or PCC, for describing recurring strategic mechanisms in competitive and adaptive systems. So a lot of this started from my observations of different sorts of dynamics and different systems of like game theory and game theoretic type places in which there would be these three sort of forces, pressure, chaos, and control, that you can observe. P, C, and C, or I guess chaos could be written as CH, so we don't have the two same ones. You guys can see my screen, right? I'm sharing my
Yes.
Yeah, this is my GitHub repository, PCC. So basically, the important thing about this is that it's a rock, paper, scissors type dynamic in which pressure beats chaos, which beats control, which beats pressure. So what I'm saying is that within a lot of systems, like whether it's like a game like poker, which I can actually show right now, PCC poker. You guys see this repository, right? PCC poker.
Yes. Yes.
Here it is. In a falsified game of leaded poker, every decision has an explicit information state, legal action state, and the alternatives, which do demonstrate the PCC triangle of pressure, chaos, and control. Here's everything I've implemented here. So this has taken a lot of coding from my perspective and a lot of help from some LLMs too. But basically, we've more or less demonstrated that this holds true in some specific games, like poker, as well as in liar's dice, which is another common one used in game theory type work. PCC for liar's dice. As well as some like fighting and battle type games. My updates for OREL right now are that the research program, we have this universal repository PCC, as well as the experimental environments for PCC poker, the other ones like for liar's dice. I'm trying to show across all these sorts of games that there could be a mechanism for control and mechanisms for pressure, for chaos, and control, that it can be independently replicated, that we can have a deliberate negative control of RPS, PCC RPS. So in this repository, PCC RPS, we're also trying to show that, like what I've described by this thing like pressure beats chaos or beats control isn't some arbitrary thing that I've made up. So this is a negative results, a negative control against those other two. I'm also trying to prove that it holds true. In spatial environments too, with this repository PCC Microfighter. This is a one-on-one fighting game laboratory in which you can see whether or not in differences of space and time that the threats emerge between two people that fight one another would hold true as well. So like it's not just for things like poker. Surprisingly, some games you might think of in which this rock, paper, scissors, like some games you might think of ordinary for scientific experiments, like chess, are not good experiments. Chess is not a good laboratory for this. Chess simply does not have the behavioral capacity for those sorts of experiments between three different sorts of things. And once again, just to reiterate, since I know I'm going with this very, very, very quickly, pressure, chaos, and control are three different types of information states that you play. In pressure, you want to drive change, amplify, or optimize some sort of thing in front of you. For chaos, which often gets misunderstood as randomness, chaos is not randomness. It's about variability, disruption, and unpredictability. And for control, you want to stabilize and regulate and constrain the game. So think like being very rigid, very rule-based, maybe even trying to predict someone else's move. Here's how they interact. Once again, chaos beats pressure, or chaos beats control, control beats pressure, and pressure beats chaos. So this produces cyclic dynamics, instability, oscillations, and transitions. And we can look at things overall with this repository for cross-game, PCC cross-game. So this gives you an overall view of where I'm at with the actual experimental work. I have a paper that oops. I have a paper that I'm almost ready to submit. Let me see if I can get it. I have a series of papers actually, including one that I've submitted to I submitted a pitch to Cybernetic Futures as well too. That was the contest. I think Jesse shared it. So whatever happens, happens. If yeah, this could be presented as a means of AI stability, as a relationship, not an intrinsic property. Yep. So we can ask ourselves, what forms of intelligence are our feedback architectures producing, stabilizing, and excluding? And see if there could be this second order move between our rock, paper, scissors going on right now, between pressure, chaos, and control. In any case, it's all about, things are still very, very, very exploratory right now. But so one paper is under review right now at AIP Advances, and it's been under review for a very long time. So maybe I'll try to message them and see if it's like what the status is. I have a few other papers. I don't want to go into too many details right now, but you can see some of my work here, like reaction diffusion systems, entropy fixation dynamics, information geometry, and entropy as the unifying thing is that we have entropy as a universal potential universal observable of different systems that relates to stability itself. So that's what I'm trying to. If I can prove that that sort of thing holds true, this could be potentially a new branch of mathematics, or a new subfield of mathematics research. Entropy-based instability dynamics, EBID. So that would be the overall like subfield, and PCC would be like. So basically, with EBID, we want to show that from this there is a link between entropy and instability. So, seeing as how we found some specific entropic-like factors that could explain these sorts of relationships across different systems. So, yeah, I'm happy to take any questions or any comments or critiques.
Yeah, that's great. Thank you for that overview. And it looks like you've got some GitHub repositories that are really interesting. So
Yep.
you've worked out some examples. And, yeah.
And I first saw it in video games of all places, like Street Fighter, Super Smash Bros. I even considered downloading data from competitive gamers, but it was just too confusing. And you also, believe it or not, from a scientific perspective, you can't do that without consent. So it's better for me to simulate with. Oh, yep. You need consent for that. So
well, I think
but
starting simply for like the different examples is good.
You can see it in StarCraft players too. So it's interesting stuff. Yeah. So
Yeah,
sorry, I didn't mean to interrupt.
Oh, well, I mean, a lot of times people will benchmark reinforcement learning models, machine learning models on the different video game benchmarks that they have. So this is kind of similar to that. And in fact, you could probably do that with, I don't know if they have a StarCraft benchmark, but
yeah, I don't know. That's a good question. Like Hugging Face or Kaggle. Yeah, it looks like they do their esports data for StarCraft and some other games. So that's interesting stuff. But in any case, starting simple, or just to get the data of the systems together, I think it's just really exciting how across not just like one specific game like poker, but a few different games like poker, liar's dice, like a simple like fighting game like I can code myself. The patterns do emerge. So that's really fascinating. That's like a signal you got to follow there. Whether or not we want to apply this to the work from OREL, like embryogenesis, we'd mentioned control systems like even like Breitenberg vehicles, like what Bradley was just talking about previously. Basically, like with pattern formation, like you want to regulate the instability between like the morphogen gradients would be pressure, the regulatory networks could be control, and then chaos would be the stochastic variation. Yep, from an embryogenesis perspective. Yeah, we can keep talking. We'll keep talking about this.
Yeah. All right. Yeah, let's do that. So again, yeah, thank you for meeting today. Everyone's updates. Yeah, we have a lot of things in the chat, so check that out. And see you next week.